And then Benjamin did a postdoctoral project with Cornell Lab of Ornithology. And it was during that time where I met him in 2022. He was doing a project, he was putting up very sensitive microphones at various locations up and down the Appalachian Mountains to look at fall migrating birds at night. And he approached us at our Rockfish Gap Hawk Watch. And he came down and I took him up on the roof of our old inn and he put a microphone up there and with a big battery and it recorded every night for almost 3 months, I believe. And he got a ton of data. So I'm looking forward to him talking about some of that stuff today. So I'm glad you were able to come here tonight, Benjamin. And then, so Benjamin recently, last year, he went to go to University of Illinois at Urbana-Champaign as an assistant professor in the Department of Natural Resources and Environmental Sciences. And there, his lab is doing lots of cool stuff, mostly focused on migratory birds, um, um, as well as various animal movement studies. And his research spans ecology, evolution, behavior, conservation and it looks at a lot of important questions about migration systems and environmental change. So tonight, Benjamin is going to talk about his latest scientific understanding of how migratory birds are impacted by our changing world. And that includes how birds use urban areas and the challenges they face and how we can help mitigate these issues that these birds have. And he's also going to focus on the role of new cool technologies like AI and machine learning, use of radar and bioacoustics. All that goes into his research. And he will also discuss his recent work on the sociality in songbird migration. And that that was part of his project looking at the Appalachian Mountain migration. So anyway, everyone, give Benjamin your ears. Benjamin, take it over. Thanks for coming again.
Sure. Thank you so much, Vic. Thanks for introducing me from afar. Yeah, it's great to be with you all. Let's see, let me start my screen share. Always the fun part. Um, I assume this is looking good, but if not, someone holler. Um, Thank you for that introduction, Vic. My name is Benjamin Van Doren. As Vic said, I'm at the University of Illinois at Urbana-Champaign, and I do a lot of research related to bird migration and global change. So today I'm going to talk about um, a few perspectives on bird migration. There was a lot in Vic's introduction, so worrying that I bit off more than I could chew for today, but we'll see what happens. Um, I'm going to start by just talking generally about nocturnal bird migration, which I'm sure most, if not all, of you are familiar with, but it bears repeating and is super fascinating anyway. So of the roughly 11,000 bird species in the world, about 20% of them are migratory. Fewer of them are migratory down in Costa Rica, where Vic is right now. But in North America, we have 70% of our bird species being migratory. And that's because we live in a temperate zone. It gets cold in the winter, as we all know. And migration is a response to seasonality, to colder weather in the winter and a lack of food resources. So most of our birds leave in the winter, and they do so generally under the cover of darkness. So nocturnal bird migration is the dominant mode of migration for these birds, and that's totaling billions, 4 billion individuals, as I think a fairly good estimate of the number of birds leaving and entering North America each spring and fall. So that's a huge amount of birds moving under the cover of darkness, where typically we can't really see them. Why do they do this? Why do they migrate at night? Well, there are a number of plausible, reasonable explanations for this. They range from it being cooler at night to the atmosphere being more stable. There's no turbulence like we see during, or less turbulence compared to what we see during the daytime. Of course, no hawks can see these birds migrating at night unless say, they're illuminated by buildings, but we'll get to that later. And there are navigational cues that become available at night, such as the stars. So with this in mind, I want to first talk today about urban areas and migratory birds, touching on how important they are, but also the risks that urban areas pose for birds. Being in Chicago or near Chicago right now, I figured I'd show a couple of statistics from some research that I've done recently. And our estimates are that nearly 100 million migratory birds are passing through Chicago, the Chicago area in the spring, and over 150 million in the fall. Um, and on eBird, people are seeing hundreds of species in an urban area like Chicago. So just one example of a city, a metropolitan area that is certainly a biodiverse place with tons and tons of birds. Um, Part of my research requires, I think, a rethinking of what we generally perceive of as habitat. So when we think of habitat, we might, especially in the context of an urban area, we might think of fields, forests, shrubby patches like this. Um, but airspace, increasingly, I think we should need to recognize is also a habitat. Airspace, the atmosphere is where birds spend a lot of their time. They forage, they can even rest there, but certainly they spend a lot of time and energy in the airspace. So some of my research involves understanding how migrating birds in particular are using habitats both on the ground, terrestrial habitats, classic habitats, and those in the sky. So in Chicago, we're working to identify areas that are higher, what we would call higher traffic airspace, where lots of birds use, the flight paths that lots of birds use, and also how they behave as they're moving through the city. How do they navigate the obstacles and the risks of an urban area? And how do the places and structures on the ground shape how birds navigate a built-up place like Chicago? And to do this, we are turning to technology. So this is where the technology comes in. We have deployed a bunch of recording devices, mostly audio recording devices, shown on the map here. These mostly orange circles represent our audio devices in our network right now. These are microphones that are positioned on the ground, listening to pointed to the sky and listening to the sounds of birds as they fly overhead. We also have some thermal cameras, which I'll get to a little bit later. And combined, this network of devices is allowing us to gain some insights that would otherwise not have been possible, especially about these nocturnal movements that are occurring unseen by most people. So we have devices for everywhere from the tallest building in Chicago on top of the Willis Tower, formerly the Sears Tower. If you've heard of it, that's pictured on the left, high above the city, and in backyards and green spaces, preserves and the like on the right. We have a whole crew of people who have been helping out with this research. A few of them are pictured in the middle on top of the Chicago Symphony Orchestra building, which is one of our sites. And through these efforts, we've been deploying these devices across the city and starting to get some exciting insights. Now, this project in Chicago has only just begun. Last fall was the first season, so we are still crunching the data, or starting to really crunch the data. But I want to share with you a couple of our initial insights and just what we're doing with this project. So one of the exciting things that we are doing that builds on some of the work that I did in Appalachia that I'll get to later in the talk is deploying microphones, these acoustic sensors that are listening to the sky, listening to birds overhead, that are internet enabled. So they're connected to the internet and they can transmit data to our servers in essentially real time. And this allows us to see what's going on essentially right after it happens. So this is a dashboard that you can find on our website for this project, chicagobirdmigration.net. And this dashboard shows the sites that we have. On the left, the circles show our locations, with the larger circles indicating areas with more birds detected. We can see on the right a time series, the screenshot I took in September last year. A time series of the detections we're picking up from our audio devices, and on the bottom right, a species breakdown of what we're detecting. Now, you might be wondering how we're actually detecting and recording all these birds in real time, these thousands of birds. And the answer is that we are using machine learning tools like the ones that power the Merlin and BirdNet apps that you may be familiar with on your phone. So Merlin has gotten pretty popular. So I'm guessing many of you have used it. It's a smartphone app that will automate the identification of bird sounds. You can turn it on, go outside, and it'll tell you what it's hearing, and it works quite well in my opinion. It's not perfect, but humans aren't
Yeah.
perfect either. The devices that we're using, the software that we're using is kind of an offshoot of the same kind of software that Merlin uses. So it's machine learning software that scans through audio and pulls out the vocalizations of the birds. It's required a lot of effort for us to build this model and train this model. And I won't get into the details, but I'm happy to answer any questions you might have about that. But it's something that we can use to process these thousands of hours of audio coming in real time. Now, one of the cool initial insights that we're getting from Chicago using these acoustic devices in real time are sensitive species that we might not be able to detect otherwise. Upland sandpiper is one example. It's a species that is hard to find in a metropolitan area for sure. It's a species that's been declining, but it's a species that we are detecting on our network. We've detected dozens of these birds flying over Chicago. This was last fall, and in contrast, only one person, one eBirder, reported a visual observation of an upland sandpiper in the Chicago area last fall. So we're getting insights that otherwise people on the ground would not be able these birds we wouldn't be able to detect otherwise. So that's been really exciting. We're also turning to tools like radar, Doppler weather radar, the same source of information, the same technology that powers meteorology essentially for the country, is also able to detect migrating birds. And we can use this not only to see what's migrating overhead in the atmosphere, but also where they spent time on the ground, where they stopped, rested, refueled, and identify the valuable habitats that birds are using on the ground. So on the right are two images. On the left of the leftmost of those images is a radar visualization of one night in Chicago. And the darker green blobs, we see some linear green blob here and some blobs towards the bottom. These darker green areas are parts of the atmosphere that are starting to fill with migrating birds as they are taking off on nocturnal migration. This image was taken just 20 or 30 minutes after they started to take off. So a consequence of that is that we can actually see the airspace or the airspace that these birds are occupying gives us an idea of where on the ground they had been hanging out, where they had been spending time before they launched into nocturnal migration. So in these first images after birds start to take off in migration, we can actually see the parts of the airspace that corresponded to where lots of birds were on the ground. And I've drawn orange rectangles around these blobs because they correspond on the right to the green spaces that we have in the Chicago area. So we can start to see that, for example, there are lots of birds taking off over this particular green space, so we can infer that that area was a place lots of birds had been spending time foraging, refueling, resting before they took off in migration, and we can use this information to identify the most important habitats that birds are using as they are stopped over for migration. So radar is another tool that we use. I mentioned thermal imagery. There's a little inset image on the left of one of our cameras. And this is just a really quick video. You'll see a few blobs moving over the screen. There's one going from right to left. And thermal imagery data allows us to see the dots that represent birds overhead, which we wouldn't be able to see otherwise. And acoustics, though it can tell us about the species that are flying overhead because we can identify the calls. We don't know how they're behaving as they're flying. And so if we want to know how birds are responding or being affected by forces like light pollution, it's really important to know how they are behaving in flight. And thermal imagery is one way we can see how birds are behaving as they fly through the night sky. So these are some of the tools that we're using for our research. And I want to step back and ask a question of, I said that there are lots of birds in cities, but I think it's important to ask, just why is that, and is that actually a good thing? Um, there are many reasons why cities may be important for birds. Some of them might relate to just their geographic location, say on a coastline or a lake, or in embedded in some good habitat, perhaps, or nearby some good habitat. But there's also another factor, which I've alluded to, and that's light pollution. The amount of light emitted by cities creates this glow, the sky glow above the city, and increasingly, research is showing that this sky glow that cities emit is an important attractive force for migratory birds. To put this in context, cities represent only 2% of the land mass in the US, but emit over a third of all of the light output from the whole of the country. So there's a tremendous amount of light that comes out of cities, and some research that my colleague Kyle Horton at Colorado State University did recently is showing that sky glow is actually a very important predictor of where birds are stopped over on the ground. So his research, which I've shown a couple of images of on this slide, looked at where across the country birds are, migrating birds in particular, are spending time during stopover. And the yellows, the greens, these areas, I believe this is in fall. These are areas that lots and lots of migrants spend time on the ground. And he can use some statistical models to try and explain what factors influence their choice of habitat, of stopover habitat on the ground. And Kyle found that sky glow, this light pollution, is the second most important predictor for where birds actually stop over on the ground. Now, I want to highlight this is when I say important, it doesn't necessarily mean that's a good thing, but it means that it is something that birds are clearly responding to, for better or worse, as they make decisions about where to land. So I've said that cities are important, but this is a good introduction, a good segue to the fact that they are also areas that are risky, potentially quite risky for migratory birds. And light pollution, I'm going to focus on light pollution. As I mentioned, it is something that drives how birds make decisions where to stop. They are drawn in by this light. And a really dramatic example of light pollution is that of the Tribute in Light Memorial in New York City. Only happens one day a year, but it's a light display that is extremely bright, shines up into the sky, can be seen by up to 100 kilometers away. And as a consequence, it has provided a really exciting, useful, important opportunity to study how birds are responding to light pollution. So when we did this research, we wanted to understand just how far does the effect of the lights extend from this tribute, from this light display. And the video you're seeing here, hopefully it comes through okay through the screen share. Hopefully you can make out there are some white dots that are moving around, especially in the center of the image. These are migratory birds that have become trapped in the light beams. This video is pointed up into the sky. Imagine you're lying on the ground looking up and seeing these dots, these birds moving overhead. These are thousands of birds that have become trapped, as it were, in these light beams and are flying in somewhat circular paths and essentially increasing in number over time as the lights stay on. So some of our research we've done attempted to look at just how big of an attractive force these lights are. So we turned again to this radar tool, Doppler radar, that the government, the National Weather Service operates. There happened to be a radar about 100 kilometers from Manhattan. And the radars, they send out a beam of energy into the night sky. And the beam spreads out, it gets a little bit wider as it moves away from the radar, it gets a little bit higher into the sky. And that means when this beam reaches the area over Manhattan, which I've represented here, it's sampling the airspace about 700 to 2,400 meters above the ground. And this means that any birds that are moving around in these lights in this airspace would be reflecting energy back to the radar, which we can use to quantify the number of birds that are milling around in that airspace. So what does that look like? Well, here's an image of the data we can get from the radar, and to orient you, um, here is a I'm tracing with my mouse. Here is an outline of southern Manhattan. The Tribune light is in the center, and this is an image where the lights in the Tribune are off. It's about 10 p.m. on the night of September 11th, 2015. And our estimates are that there are roughly 500 birds in the airspace around this location. But then the lights are turned on, and just 20 minutes later, there's a huge aggregation of birds that we are picking up from the radar. 20 minutes later, we estimate that that 500 count has ballooned to over 15,000 birds that are in this immediate area of southern Manhattan. So clearly, these lights have a dramatic impact, and we recorded this over several years. We estimated that over 1 million birds were essentially drawn off course, attracted to these lights. But there's a silver lining to this particular location, and that's that these beams, these light beams, are turned off if too many birds become trapped in the beams, because there is a partnership between um, advocates, the New York City Bird Alliance, and organizers of the events, which mean that if too many birds become trapped, they turn off the lights temporarily. So as a result, there's been relatively little mortality at the site, which is really fantastic for the birds, but also isn't the norm when we think about cities and lights and the glass that is behind most of the lights that are output by cities. So of course, when we have glass involved, not just empty airspace, um, too often we get situations that involve collisions of birds.
Oh,
Chicago has been
hurts my
a
feelings.
place with lots of documented collisions. New York City has been as well, but collisions and bird migration are a global phenomenon. It happens in New York, but it also happens in places like Germany, where a particular building called the Post Tower in Germany has been the site of research on bird collisions mediated by light pollution. We have Chicago. We also have places like Singapore, which also experience bird collisions. So light pollution and bird collisions are a global phenomenon. Um, but focusing on the area that we studied for the purposes of our talk today, if I reorient us towards Chicago, I want to talk about what just now a little bit of a little vignette about how we can mitigate this impact of light pollution on birds and their collisions. So Chicago is one of the cities that some of our past research identified as the city that exposes the most migratory birds to the most light pollution, simply because Chicago is a big city on an important migratory flyway and is a very brightly lit city. Dallas and Houston are numbers 2 and 3 if you're interested. And there's a building in Chicago called McCormick Place, which I've highlighted in red here in this 3D rendering. It's a building that's a low-rise building, but it's a site that has been monitored for bird collisions for decades, thanks to the really Herculean efforts of Dave Willard at the Field Museum in Chicago and his group. And Dave and his team have walked around this building essentially every day during the migration season for something like 40 years now, and they've recorded all of the collisions that they've found, take them back to the Field Museum so they have second lives as specimens for science. But they recorded also not only the birds and where they found them, but the lights, which lights in the building were illuminated. And so we were able to use this information to model statistically what would happen if lights were turned off versus turned on in this building. And we were able to show through our research that if more lights had been turned off, there could have been 50% fewer collisions at this building, but that if all lights had been turned on, 75% more collisions might have happened over the course of a 20-year study. So the lighting at this building really has a big impact on whether birds are colliding here. And this plot shows years on the x-axis, so years of this study, and on the y-axis, the number of birds we either expect to be saved or to have died if the lights had been in those different settings, essentially. So light has a really big impact on bird collisions at this particular building. Now, I hope I've convinced you that light is an important thing to think about for the safety of migratory birds, and that it's important to find ways, if we can, to turn off lights, to shield lights, to take action to develop our buildings in more bird-friendly ways. And one way to um, get the word out about this issue is through, I think, the dynamism of bird migration. Bird migration is such an exciting phenomenon that if we can bring people into the fold of bird migration through quantifying it, predicting it, and providing them a window onto this vast nocturnal phenomenon they otherwise wouldn't perceive because it happens overhead as they sleep, that we can be better off in building our networks of people interested in making a difference. So I've been involved with the Birdcast project for a number of years now, dating back to my Cornell days, as Vic mentioned. And one of the things that we've done at Birdcast is to produce bird migration forecasts, something I worked on several years ago now. And bird migration forecasts are useful because they can tell people when and where birds are occurring. It's exciting for birders like me and like many of you, I assume, to see a map that shows, well, here in my location, there's going to be potentially millions of birds migrating overhead tonight. This is a forecast map from May 2023 that shows in yellows, the brighter yellow colors, areas that we think, or our statistical model thinks really, will be experiencing lots of bird migration. So we can produce these forecasts, but also we can take this information and make a reasonable guess about, or reasonable assessment about where are the most important areas for people to turn off lights to protect birds as well. So we can take these migration forecasts and convert them into lights out forecasts, for example. And in this particular night of mid-May migration, it's not surprising that most of the US is covered with a red color indicating a high priority night to turn off lights if possible. So that's something that we've worked on, and I'm really proud of. If you go on the Birdcast website, you can see this information. I think we're live now in March. I always forget if we start March 1st or March 15th. But if you go on Birdcast either now or in a few days, you'll be able to see these forecasts and enter a location and see if we're predicting large numbers of birds at your location. So this forecast, if I go back a couple of slides, was predicting lots of birds in the eastern US. And sure enough, if I look at what actually happened, the image from the radars, I can see that this was a big night of migration across the east. This is an image from a visualization, really, that a colleague of mine at Cornell has produced and still produces for the Birdcast website, with the brighter yellow colors indicating data straight from the network of weather radars processed to extract birds, to try to eliminate as much precipitation as possible, and then estimate the number of birds that we're seeing pass through the airspace. So in this particular image, our estimates were that over 600 million birds were moving through the US airspace on this particular night. So huge numbers. One other thing that we've released in the last couple of years on Birdcast is a dashboard with lots of charts and statistics. So you can enter your location, and if you had been in Chicago on the night of September 20th, 2024, and entered your location on our dashboard, you would have seen that over 9 million birds were passing over Cook County, Illinois, one of the core counties of Chicago, on this particular night. So this is a way you can not only see the numbers of birds passing overhead, see what's been going on in the season, see the species that we expect to be moving through, and a few other exciting tidbits like the altitudes and flight speeds and whatnot. So bird safe, an important bird safe action like turning off lights is really easy to say. It's something that needs to happen, but it's harder to actually put it into action because we have to change minds, we have to change behavior, and it's harder to do that than just talk about the science. The work that we've been doing, though, has garnered a decent amount of interest in the press and in the public. not only from the written word, but also some government action has occurred as well. In Illinois, there was a Bird Safe Buildings Act that passed a few years ago. In New York City, there was a bird safe building or lights out legislation passed by the city council. And if I come full circle back to McCormick Place, which is this building that for 40 something years had been killing thousands and thousands of birds. Just this past summer, they installed finally bird safe glass or bird safe glass treatment on their windows in this facade facing the lakefront. Hopefully you can make this out okay. These are our dark glass panels with white dots in a regular grid pattern. Especially you can focus on the left plot with the which has a zoomed in image. These regular dot grid patterns are designed to break up the reflection of the glass, and so far it seems to have been quite effective in really decreasing the number of bird collisions at this site. So there are actions we can take, like turning off lights, like treating glass. Both of these are important to making a difference to protecting birds in urban areas, especially. So I want to put a pin in the urban area stuff and transition to back to nocturnal migration and think about how birds are actually finding their way. Now, if you're a songbird like a scarlet tanager, say, that hatches in Virginia in the fall in the spring, the summer, rather, sorry, hatches in the summer and in the fall is attempting to go on your first migration. The conventional wisdom is that you, as a young songbird, are not being shown the way by your parents or your friends or your peers or anything like that. That it's totally up to you to find your way from Virginia all the way to, say, Peru. And I've put a couple of quotes from scientific papers that highlight this, that it's thought that the majority of songbirds are relying on a genetic program to find their way. These are, what I mean by genetic program, I mean that essentially there's an instinct that tells them when to depart, where to go, and when they've arrived. But increasingly, there's been more and more, I would say, hints that bird migration involves more social aspects than had previously been understood. So there's some experiments that say moved shorebirds, godwit chicks specifically from the Netherlands to Poland, and found that these birds seem to use cues from the local birds, so they seem to demonstrate some social learning to figure out where to migrate. Some fine-scale radar data suggests that birds don't entirely move on their own when they're migrating at night, that they seem to fly in some sort of loose aggregation. And whether they give flight calls, whether they give these vocalizations as they're flying, some species do and some don't. The species that do seem to be more susceptible to collisions and be more susceptible to being drawn in by light pollution and therefore colliding with the building. So it seems that the social communication, the social aspect of migration may be more consequential than previously understood. And some of the work that I've been thinking about recently, or the research questions I've been interested in, include whether these birds could actually be interacting during migratory flights at night, passing information to each other, and otherwise communicating in a way that currently science doesn't fully appreciate. So this brings me to the work that we did in Appalachia. So the research that I'm going to talk about today involves this network of recorders from across Appalachia, these yellow dots. And I have a zoomed in image here. Rockfish Gap is right in the center. We had a couple sites in Virginia, including the Mountain Lake Biological Station. And going back to the previous slide, this network of Appalachian recorders was combined with some other data I had from southern New York and central New York. And combined, I'm sorry, my mouse keeps advancing when I don't want to. Together, we had about 18,000 hours of audio recordings across fall. All of the yellow recorders, the Appalachian recorders, were recording in fall 2022. This is a picture that I'm sure some pictures that Vic sent me from that our encounter in I guess I don't remember if it was August or September 2022, but this is when we went up onto the roof of the inn and we set up my jerry-rigged my recording setup, which involved a solar panel, a bucket, a cinder block, and a burlap cover over a waterproof case. This was inside the bucket with a microphone pointed at the sky. I want to share with you some of the one snippet of recordings that we recorded. If you're wearing headphones, just be aware. I don't know how loud it may or may not be for you. Hopefully the screen share shares audio successfully. If not, then it won't take too much away, but I'm going to try to play this now. Before I play it, I'm going to orient you to what you're seeing. On the y-axis here is frequency, so the pitch of a sound, and on the x-axis is time. So we see four different marks here on the screen that are kind of slashes. These are little downward calls of birds. And as I move through the video, you'll see a few more and hopefully hear a few more as well. So let's go. Let's try this out. Okay, so you probably heard a lot of noise, road noise, machine noise, some electronic interference, but hopefully you also heard a few high-pitched bird calls as well. In the middle here is the call of a white-throated sparrow. We've got some chipping sparrows flanking it. Here's another white-throated sparrow. I'm just looking at the spectrograms here. There's another really nice white-throated sparrow. So these are some sparrow calls. On this recording, some more chipping sparrows. The beginning, these are some what look like probably northern perilous. So a diversity of birds that were recorded. These are all recordings from October 2022 from the Rockfish Gap site. If you look at the pattern of what we recorded at Rockfish Gap through the season, we recorded some peaks of migration or calling anyway, in September, and especially large numbers in the second half of October, before migration tapered off into November. Rockfish Gap was actually one of our best sites for sustained recording through the season. We had some technical difficulties at other sites, but I have to say this site did a fantastic job. We recorded a huge array of species. All of these have been, or almost all of these have been manually verified. They're in taxonomic order. Hopefully, sorry if the text is a little bit small, but my mouse really doesn't like me on this presentation. Anyway, we have green herons at the top, just a handful, veeries, gray-cheeked thrushes, lots of Swainson thrushes, over nearly 1,000, nearly 2,000 chipping sparrows. Rockfish Gap was the chipping sparrow capital of Appalachia for whatever reason in our network of recorders, and I'll get to that a little bit in a minute. Lots of white-throated sparrows, smattering of other species, lots of Cape May warblers, rose-breasted grosbeak. So we recorded a huge amount at Rockfish Gap. That's on the left. On the right is a combined accounting of all of our sites recording. So you can see Swainson's thrushes really dominate the recordings across our stations. But for whatever reason, and this is super interesting, I think, at Rockfish Gap, Swainson's thrushes have played second fiddle to the sparrows, which actually really surprised me to see. I don't have a good explanation for it, but maybe it has something to do with the routes that birds are taking, the ones that are following the spine of the Appalachians versus a little bit further east where Rockfish Gap is, kind of a satellite hill mountain, if you will. So maybe there's some interesting migration route stuff there. I'm not really sure just based on these information, but lots of rich insights there that could be dug into. This really garish plot, I apologize for that, shows the proportion of different species detected at each site, and Rockfish Gap is the purple one. So Rockfish Gap recorded fully 90% of all the chipping sparrows that we recorded across our network, 67% of the tree sparrows, 80% of the white-throated sparrows. So something was going on with the sparrows at your site. 59% of the white-crowned sparrows, but only say 30% of the perilous, 28% of the Cape May warblers. So really some interesting patterns there that could be looked at in more detail. My final slide, which is even more complicated, shows the seasonal pattern across all of the species, and I'll just highlight a couple of them. So on the upper left here, this plot, if you can make it out, shows our detections of veeries, which primarily occurred in the early part of the season, in early September, petering off by October. Whereas, what's a good example? Our chipping sparrows were peaking in October, mid-October into November, and other species had different patterns. So we see a lot of fine-scale information here into the timing of birds' migration, when they were passing over Rockfish Gap. Be happy to provide the finer details if any of you who are birding out there or at the Hawk Watch want to match to your own visual observations. But we got lots of data, so I'd say it was quite a success. So thanks so much to Vic and anyone else who helped facilitate that effort. Now I know I'm running close to the end of my allotted time, so I'm going to provide an abbreviated version of the rest of the talk. Just highlight a couple of things that we looked at in this broader research that united all of the Appalachian stations and those other ones. We wanted to see whether these migrants could be interacting as they're migrating overhead. And the short of that is we looked at when they were recorded over time and tried to determine whether the calling events that we detected, the calling events of one species, were linked to the calling events of another species. In other words, do you find black and white warblers calling with American redstarts or totally independently of American redstarts? Are there certain species that like to fly together, to vocalize together, or do we actually detect just a random aggregation of calling? Here is an example time series of detections of American redstart calls from just a selection of a few minutes. And each dot is a call. So we have 2 calls there, 2 calls there, 3 calls there, 1 call there. And if we look at when black and white warblers were detected in this particular time series, the 2 black and white warbler calls we picked up were right next to the American redstart calls. So it seems likely that this bird was migrating with the redstarts. This black and white warbler was migrating right next to the redstarts, essentially, and vocalizing in turn with those birds. So this information can tell us on a wider scale, is this kind of pattern, was this a fluke, what I'm just showing on this slide, or is this a wider pattern? And the long and short of it is that we picked up broadly a signal of connection among these species. And we can make a network of the species that tend to call together when they're migrating. These 6-letter codes are codes from the eBird database, so I apologize. They may not be a little bit obtuse, but I'll just tell you what a few of them are. So they're colored by family. The greens are sparrows, so we have white crowned sparrow and Savannah sparrow and white-throated sparrow tend to like to vocalize together. The warblers on the left here, this light blue, tend to vocalize, prefer calling together. And the thrushes and grosbeaks and even herons tend to like calling together in migration. So we pick up this signal that instead of being lone birds heading off on their isolated migrations across the world, they do seem to be communicating with each other as they're flying more than we previously understood. Now, the implications of this are that their vocalizations, their flight calls, sorry for this scientific language. I'm gonna just listen to what I'm explaining. Their flight calls are potentially driving this structure of interaction aloft, and we have still a lot to understand about how they may be interacting and what it actually means. But we did find that their vocalizations are important, and we did find that the birds that are flying at similar speeds tend to be detected calling um, close in time to each other. They tend to be aggregating during flight, which makes sense because birds that tend to fly at the same speed could be better able to maintain some sort of connection as they're flying. Um, in contrast to a species that flies faster than the other, that faster flying species would probably just pass the slower flying species and not be able to actually stick with it. So flight speed is important. These vocalizations are important. But more broadly, these social connections during migration might be more important than we currently understand in these birds making decisions about how to migrate. And in the context of declines that birds are experiencing in the present, it's likely that these interactions that are occurring as birds are migrating are decreasing, are becoming less frequent over time. And we don't really understand the consequences that this might have for how birds navigate, how they interact, how they find their way, and what that means for their survival. So there's a lot that we still need to learn about the consequences of these social interactions. But thanks to our recordings at Rockfish Gap and elsewhere in Appalachia, we're able to get a hint that there's more out there to find. So that keeps me busy as a scientist. I think I will end there, open up for some questions. Thanks so much for listening. And if you don't get to ask a question, feel free to contact me at vandoren@illinois.edu, and I'll do my best to answer your question. Thank you for being here.
Benjamin, on behalf of the Augusta Bird Club and the VSO, it was an awesome talk. Wonderful stuff. It's not easy research. So kudos to you and good luck with all your research. I'm going to hand it over to Rich and our club members for some questions, and I'll be signing out.
Thanks, Vic.
Thanks again.
Okay. Benjamin, can you hear me?
I can.
All right, Rich Wood here. Thank you so much. Wonderful stuff. I mean, just fascinating. So does anybody have any questions for Benjamin before we leave? I do. So I think about this like a subway in New York City in rush hour. So my question, Benjamin, is, do the birds know when to land at night? Do they all decide we're all going to go down here at one time? I mean, they travel further. How do they know? Is there some kind of something that says, okay, this is your stop. It's time to rest for the night?
That's a fantastic question, and one that I would say is still at the cutting edge of what we don't really understand. There's a lot that we don't know about how birds decide exactly where to land, but there are plenty of clues. Probably they can see habitat to a decent degree. They can see enough to make out forest versus water versus especially illuminated area versus some other kind of habitat. So they can pick up cues. And so if you're a forest-loving species, you can probably determine where would be a decent place to land. But that's only part of the question. We think that maybe also they might hear things from the ground. It's possible that audio cues, either other birds or ambient sounds like maybe even marsh amphibians. If you're a rail looking for a Virginia rail looking for a marsh, maybe the spring peepers are an audio signal of good habitat. But there's a lot we really don't know about the decision-making process involved in a migrating bird deciding where to land. And that's a really crucial piece of the puzzle to understand if we want to conserve birds, because we need to understand how they are choosing the places that they spend their time. And if we want to protect them, if we want to provide places for them to preserve, protect habitat, we want to hopefully do so in such a way that they will be likely to use that habitat. There's lots of good reasons that we wanted to answer that question, and unfortunately, I don't have a good answer for you yet. But the last thing I'll say on that is as we are able to miniaturize more and more tracking devices, get finer and finer scale insights into where birds are relative to the landscape. Once we are able to track individual tiny songbirds at a really fine spatial scale, I think we'll start to be able to answer those kinds of questions. So stay tuned for that.
Okay, thank you so much. Does anybody else have any questions?
Yeah, I've got one.
Go ahead, we have one more here.
Hi, Ben. This is Alan Larner. I was the second person on the roof with you.
Okay. Thank you, Alan.
How many species of birds that were recorded going through Augusta County?
Okay,
Do you know
so
that?
do you mean from the microphones or just on the
Yeah,
microphones?
from the microphones, how many different species of birds that passed through?
Yeah, well, so going back to one of those slides, let's see. I'm just going to count now. Seems like around 31. Seems like around 25 by my quick estimate that are on this slide. That doesn't mean so. This is only part of the picture for two reasons. One, that only some bird species give flight calls. So species like vireos, wrens, flycatchers, they don't really vocalize. And that's another mystery. We don't really know why there's a huge suite of bird species that do vocalize and similarly sized suite of bird species that don't. We still have really yet to understand the function of those calls in their migration. So they have to be able to vocalize in order for us to pick them up, number one. But number two, some of the species are really hard to distinguish. So you'll notice there's some warblers, but there are dozens of warblers that we probably recorded but just couldn't distinguish from one another. And on this slide, I didn't put up categories of groups of species that we couldn't distinguish from one another. So there are calls that we can, for example, identify to either swamp or Lincoln sparrow, but can't really distinguish between the two because they're too similar, or warbler calls that are either black-throated green warbler, orange-crowned warbler, Tennessee warbler, a couple other species, and we can't really distinguish among that group very easily. So there are those that aren't pictured here that we definitely did detect, but we weren't able to narrow down to the species level. So we definitely recorded more than just 25 species or so, even if I can't say with 100% certainty which call corresponded to which bird.
Benjamin, thanks. Great talk. On Rockfish Gap, how come there are no hawks?
Oh, well, that's a good question. So because we recorded at night, number one, we weren't picking up the diurnal migrants. There are some hawks that do migrate at night, but even the ones that do, or crepuscular migrating hawks at dusk and dawn, they don't seem to vocalize, as far as I can tell, very much when they're migrating. So our acoustic recorders just weren't the right tool for picking those up.
Okay, thank you.
Yep, thank you.
I have a question. Is my audio on?
Excuse me. On behalf of the Augusta Bird Club, we're going to jump off of here. So thank you so much, Ben. We just want to give you a great big hand. It was a wonderful presentation.
Thank you.
Hey, Rich, before you guys jump off,
Yes.
on behalf of the VSO, thanks so much for partnering with us. This was absolutely fabulous, and we'll look forward to more of the same in the future.
Sounds good, Diane. Thanks so much. Thank you so much, Benjamin.
I have a question.
Yes.
My question is, maybe you do this. They've been talking about quantum effects on bird migration, and I've tried to. I'm a scientist. I sort of understand what it is.
Yeah.
But it also, since it goes through the eyes, I was wondering, is the light at night influencing their ability to migrate in quantum effects, or is it simply visual?
That's a really great question. Did you hear the recent Radiolab episode? Is that why you're?
No, I didn't.
No? Okay. There was a recent just I think 2 weeks ago called Quantum Birds maybe on Radiolab. It's a good one to listen to.
Great.
But yeah, so for those who aren't familiar with this idea, the birds are thought to or known to navigate using the Earth's magnetic field, among other cues. And it's thought that the compass mechanism by which birds can sense the magnetic field is possibly mediated by some really bizarre quantum chemical interaction in the bird's eyes that involve a molecule that takes on a magnetic characteristic when it is struck by light, by photons. I didn't practice explaining this. I'm going to do my best. But the core of your question, I think, was about whether light at night is impacting that. And that's a really great question. It's thought that the magnetic compass mechanism, if it is indeed this hypothesized light-mediated quantum mechanism, which I should say, in my opinion, isn't 100% known or proved yet. It's a good theory. It's probably the best theory at the moment, but I think the jury's still out on whether it's the case. Regardless, that is going to be sensitive. If that is the mechanism, it is sensitive to light levels. And so very likely light at night would have some impact on it. Exactly how or why, or exactly how or what effect it has, I'm not sure. Magnetoreception research, so how birds sense the magnetic field, is notoriously difficult to do because it's really challenging to keep birds in controlled conditions that would allow you to isolate the effect of the magnetic field from other effects. And so it's really difficult in a wild context to understand how something like light pollution is impacting that. But it is the case that, or there are studies at least to suggest that electromagnetic radiation from cities, other stuff from cities, could be interfering with that complicated quantum mechanism. So either whether it's light or radio frequency noise, there's probably stuff that we're doing that is interfering with those navigational senses.
Great, thank you.
Yeah.
Going back to the beginning here, how is it that Swainson's thrush dominates the auditory data, and are birds being fooled by sky glow to think it's daytime?
Or two questions. So actually, I just turned off my screen share, so hopefully you can maybe see me a little bit better if you're interested in doing so. So the first question about Swainson's thrushes. Swainson's thrushes are a really interesting example because those of you who are birders, which I assume most of you know, it's a species that is not easy to see large numbers of during the day. They're not very bold birds. They can be hard to find, a little bit skulky. Yet they are one of the most common callers at night that we pick up in the data. I don't have a great explanation for why they are so vociferous at night, but I would love to know. They're one of the most vocal species that we record, most likely very disproportionately to their numbers, but there's a lot that we still don't know about what's happening in the dark sky overhead when we're only using acoustics to tune into it. So I don't really know, but it's always seemed a really interesting contrast that they are so vocal at night and also so hard to see during the day. That's a great question. The second question about do they think it's daytime? I don't know whether sky glow itself is enough to trigger that response. It might. I do know that in areas that have been very brightly lit, like sports stadiums, for example, I know of examples where birds were, and sometimes large numbers, drawn in and actually landed and were foraging just on the ground of the sports field as if it were daytime when it was brightly lit up. So whether they think it's daytime or just behave like it's daytime, hard to know. But there's certainly some behavioral effects that are happening that are doing something weird. And I hope we'll learn more about that in the coming years. Good question.
Okay, have a couple of comments here. Diane says that most of us who field bird, at least in the Western Mountains, likely notice that fall migration is huge for mixed flocks,
Hmm.
which would support your social migration idea. Spring is much more protracted.
Yeah. Oh, sorry.
Go ahead.
Was that the end of the question?
Said spring is much more protracted.
Well, spring certainly, there's certainly contrast between spring and fall. In my my view is that fall is at least the protracted in the sense that it takes place over a longer period of time. Spring is more compressed. Usually, birds are trying to get to the breeding grounds more quickly. But these contrasts are definitely interesting, and the fact that mixed species flocks occur during migration, during when birds are in stopover while looking to fuel for migration, is I think a really interesting piece of the puzzle, and something that we talk about in our research as an important, I guess, companion to the idea that they might also be communicating during migration at night. So yeah, I'm happy to field like a follow-up question about that, but I think mixed species flocks in general are probably really important in a number of ways, and maybe there are important ways that we don't fully appreciate yet too, if it relates to how birds are finding their way or navigating, in addition to just finding food and staying safety in numbers on the ground.
Okay. Laura says, I'm very grateful to you for studying this. And she also says, I share your support for Lights Off. However, if you're not already aware, please know the American Petroleum Institute advertises, promotes, and has a website called Lights On.
I missed the advertises for what?
The American Petroleum Institute advertises, promotes, and has a website called Lights On.
Interesting. I haven't heard of that, but it's certainly the case that there are competing priorities in society with respect to light, and that's one of the it's the hard light pollution and it goes beyond birds, of course, light pollution and its impacts. It's a really interesting problem because it is a huge problem, but it's also one that we have the power to immediately remedy with enough will, essentially. I mean, immediately, compared to something like climate change, which just has so much inertia behind it that taking action now won't cause have an impact for decades to come, essentially. So I think there's reason to be hopeful about an issue like light pollution because it is something that we can have an immediate impact on if we do something about it. And it's also something that is additive. So if you make a difference in turning off lights in a problematic building that is killing lots of birds that are drawn in by light, like at McCormick Place, if we remedy that building, then we have immediate impacts, tangible impacts on saving birds' lives. So it's a complicated problem, but I think one that I have hope we can make progress on.
Okay. Several comments thanking you for your presentation. Diane mentions that the local weatherhead meteorologist in Harrisburg has been featuring migration lights out heads up.
Oh, that's awesome.
This is
That's
something
great to
to
hear.
suggest to your local weather folk.
That is great to hear.
Yeah, and then Jennifer says, great talk. With regard to the circulating light behavior seen on the 9/11 Remembrance and elsewhere, are the birds impacted by the insects who are attracted to light?
That is a very insightful question because those lights draw in a lot of insects as well. As far as we can tell from visual observations in those lights, the birds drawn in aren't really foraging. It's possible that I can't rule out that either the sight of insects or the reflectance of light off insects kind of amplifies the effect of the light. But I suspect that insects are, as far as I can tell, that insects are a minor, are a, not the dominant attractive force, that it is the light itself. But it's possible that insects are playing some role, and there are birds that do take advantage of the light to forage, like well, I said I'd mentioned like there are peregrine falcons that catch songbirds in the lights, for example. But as far as I can tell, the insect birds aren't just coming to feast on the insects in the lights or anything like that.
Okay.
Yeah.
And then she also asked, have you been surprised by any other behavior birds do at night that we have not previously understood, like building nests, etc.?
Oh, yeah, that's an interesting one. Well, certainly with light
Interesting.
influences birds' behavior quite a lot. And so if you have a lit area, um, that can influence how much a bird will sing, as well. So if it's birds that are in brighter urban areas have been found to sing more, at night, especially. So that it does have an impact on, light does have an impact on their behavior like that. In terms of other behaviors I mean, singing at night in general is a really interesting puzzle, I think. Why do there are birds, especially those grassland birds, marsh birds of open areas that like to sing at night, and if one hypothesis could be that they are actually trying to draw in birds that might be flying overhead, might be migrating. Another possibility is that they are doing something totally different. But singing at night is another puzzle that I think science has yet to totally uncover.
Okay, and then probably one last one from the chat. Might birds communicate at decibels we can't hear,
Mm.
like giraffes and elephants do?
It's thought that birds might be able to hear infrasound, really low frequency sounds. Some experiments have suggested that, for example, for homing pigeons, that they could hear really, really low frequency sounds. I'm talking about like waves on a coastline or that sort of thing. Um, but as far as science knows, as far as I'm aware, birds generally stick to something close to human hearing range, unless it's a black-burning warbler that might be too high for some people to hear. But generally, it's not thought to. Birds aren't thought to give noises that are make noises that are higher pitched or lower pitched than humans can hear, as far as I'm recalling at the moment. Um, but one thing that they do perceive that we don't is colors. Birds have um, four cones in their eyes. We only have three, and they can see a whole dimension of color that we can't see, including ultraviolet type colors, but also just the richness of colors that they see is, we can't comprehend what that means for a bird, but it's one of the cool aspects of bird senses.
That's great. Yeah. So that covers most of the questions, and there were a lot of comments thanking you for your presentation, and people learned a lot. Somebody asked about whether the recording will be available. We're going to put it on the VSO's YouTube channel and make the link available to our members and then also to the bird club so they can distribute it to the club members. So,
Great.
Diane, are you still on? Do you want to say anything to wrap this up?
Sure. This was fabulous. Thanks so much, Benjamin. And I'm really thrilled that we, the VSO, were able to partner with the Augusta Club. They engaged you to start out. And when we learned of it, we were like, oh, our members would be thrilled to see that as well. So hopefully your reach is expanded. And I do have one question for you. To support your research, if people are so inclined, what would be some of the best ways or agencies to make financial contributions? We know money for conservation is a little bit in peril right now, so please share that with us.
Well, first, thanks for inviting me again. I had a really great time. If anyone would like to make a donation, you could make a donation to the University of Illinois Foundation, and instructions for doing that and how to make it go to my lab's fund in particular to fund more acoustic monitoring devices and other projects are at my website, which is migrationbiology.org, and you can click a donate link there. So I can put it in the chat for anyone who might be interested.
Yeah, that'd be good.
Yeah, that'd be great. And then if you want to follow with an email as well, we can
Sure.
add that to the YouTube, the text of the YouTube video when we put that up.
Yep. And if you have any questions, if you'd like to make a donation, have any questions, feel free to email me. Of course, no expectation or obligation, but it is a tough time for research funding these days. So, and if you are so inclined, we would greatly appreciate it. Thanks for asking.
Thank you.
Thanks again.
It would be great to provide citizen support.
Yes, I know we're all going to need to be doing that for lots of different things. So. Great. Well, thank you, everybody. I think that wraps up the evening. And appreciate you, Benjamin, your joining us for the evening. It's very interesting work that you're doing. And
thanks for having me. It was a pleasure.
I'll learn from it. Okay.
Can I ask
Good night.
one question? Who's been funding your research thus far?
Oh, so research funding has come from a variety of sources. We had some funding from a foundation in Chicago to do the Chicago work I talked about. Some of the work in Appalachia came from when I was at Cornell, the Cornell Lab of Ornithology, and currently my work is funded as a new assistant professor. The university provides some startup funding to help a research lab like mine get going, and so we've been using some of that as well.